You've just caught us part way through, or almost all the way through, making up a serial dilution of starch to try and investigate the sensitivity of the starch-iodine reaction. So that's 0.1. Excuse me, talking to myself a second. Okay, so I've got this final tube ready. We had a half-hearted look before about making up dilutions, but we have our stock starch solution, so I'm going to move that out of the way because we don't really want that to contaminate anything else. I've got my now labelled up washing beaker, plenty of water in there. I've got my distilled water, pretend distilled water, it's tap water actually, but it's distilled water as far as anyone else is concerned. And I've got my 10 centimetre measuring cylinder. So, just to do the final piece in this sequence, I need 1 centimetre cubed, so just that washed out. I need 1 centimetre cube of this solution that has been stirred and mixed up. So I'm going to take 1 centimetre cube from there into my cleaned measuring cylinder. Plenty of eye level stuff and meniscus going on, good old fashioned science. Parallax error, etc. Going to put the remnants back into there. Give my pipette a wash out because I probably won't need it anymore, but just in case I did for another sequence down there. I've now got my water, my distilled water, and expediency I'm going to use a syringe and double whammy, get that up for my eye level. In comes my water, that should have mixed it up nicely. Please do, yep, a little bit, that's just gone. I suppose in all truthfulness that's a minuscule over. Pop that back into there, and now I've got this solution which is all well and truly mixed up, and I think that's as good a way as trying to fudge a quick way of diluting down by factors of 10. What we're going to do in a second is put some iodine solution into there and just see how sensitive our reaction would be. So come back in a second. We're now ready to look at the sensitivity of iodine in potassium iodide to detect the starch that we've diluted down by factors of 10, so from 1.0 to 0.1, 0.01 and 2 zeros 1. And for the majority of the time I prefer to use my my iodine solution, which is quite dilute that seems to come in most places. You probably notice if you've watched before that there's far less in those solutions now because I've hidden a duplicate just behind in case things go a little bit AWOL. So here we go, there's a lot of so's going on. A standard fair test, can you use those phrases nowadays, of 2 drops of iodine solution, 1, 2. I think you're probably convinced that's fairly blue, black, a go-go. 2 drops into the next one. 1, 2. I can't from here see if there's any difference between those two, but believe me, one's a 1/10 less concentrated, and then we have 2 drops. Well, I think I can see a difference in how that's being detected or not. And then 2 drops in this last one here. 1, 2, and possibly think at that point I'm getting close, maybe to where the iodine solution can detect the starch that's in there. If you think about how much there isn't, so we've got a gradation, a colorimeter range, and that's where we could start to quantify. Maybe we might need another solution after that to be even more dilute, or perhaps working some in between. But I quite like the idea of colorimeters. I think they're great. But I reckon I could now start to semi-quantify that myself by giving these arbitrary scores of, if I was to say this colour is 10 out of 10 dark or 10 out of 10 blue-black, maybe then grade the colours down as we go along here to get, say, some sort of very, very crude, semi-quantifiable colorimeter value just by using one of my dodgy retinas, just by eye. Okay, right, here we go. Iodine solution, detecting starch, so an iodine starch sensitivity, introduction to perhaps the rationale for why we would want quantifiable units of colour, hence moving towards a colorimeter investigation. Thank you.